Okay, everybody, welcome to my video here. This is for Math 8 multiplying and dividing fractions. In all the video descriptions underneath, you're going to find two links. One's going to take you to a blank copy of this notes section, and the other one will take you to the solutions or the answer key. So I won't do every single question in here. We'll try to keep it short, so that way you can try them out on your own, practice them and check the answer key to see how they went. Okay, so let's get right into it. So first thing we're going to talk about is multiplying fractions and whole numbers. Okay, so take a look at those pattern blocks. This is one of the ways we start talking about fractions early on in math, and you can recognize that you've got one whole hexagon in yellow, and you can break it up into parts. And the smallest set of parts that we use for those fraction blocks are that 1/6 piece. Now if you were to take that hexagon and imagine cutting it up, you can see that it's going to make 6 triangles. So let's just draw that again. So 6 triangles in that hexagon. So you can represent that a little differently, and you can talk about them in groups of sixths, right? So 6, 6 would make a whole. If you think about that trapezoid in red, that's a half. Well, you can cut that one up into triangles as well. And you'll notice by that laser pointer disappearing, you are going to have 3 triangles. So if the triangles each are the size of 1/6, well, you're going to have 3 out of 6 triangles there, which does represent a half if you were to reduce that fraction. The same thing is true for that rhombus. If you cut it in half, a third is really the same thing as saying 2 of those 6 that make up the whole hexagon. And, well, the green triangle is that base unit, which represents 1/6. So you can use that green triangle to build all sorts of different fractions. Okay, and that idea is going to help us when we need to represent the multiplication of fractions using a model, right? A visual way of showing this. So if I were to remember that multiplication really is just repeated addition. Okay, think about actually doing something like 2 multiplied by 3. Well, that for us would really be telling us to do 2 groups of 3. Or 3 groups of 2, because multiplication, the numbers, the order that they appear doesn't really matter. You can multiply in any order. So if I were to do 2 groups of 3, however you want to represent it, well, there are 2 groups of 3 in total, which would give me 6, right? I know 2 times 3 is 6, so let's go show this using a fraction instead. Okay, so I'm going to draw out 3 groups of 5/6. Okay, that's what our visual should look like. Now if I use that hexagon that we talked about before, 2, 3, 4, 5, 6, okay, so that's great. I'm going to actually make it look a little nicer. Nope, iPad doesn't want to be friendly. That's okay. Let's duplicate that one, and we'll do it one more time, because I do need to have 3 groups here. So there's 3 whole hexagons. The problem, I only need parts of them. So if I cut them in to pieces, each having a size of 1/6, well, in each hexagon, I only need to take 5 out of those 6 parts, right? 5 of the 6. So if I go to do a little bit of shading just to illustrate how much we actually need, 1, 2, 3, 4, 5 of each. Okay. Sorry, let me turn that down there. If you think about how many pieces we actually have in total, well, we shaded 5 of those 6 from each of those hexagons, so in total I should have 15/6. Okay, so that does get represented as an improper fraction. Now if you remember anything about mixed numbers, we can talk about splitting that improper fraction up into parts that are a whole number along with their remaining fraction. Okay, so if I have 15/6 altogether, think about how many times 6 works its way into 15. Well, if I think about multiples of 6, I can count by 6s. So 6, 12, 18. So if I had 18/6, I would have 3 wholes. However, I have less than that. So I should have 2 whole groups. Okay, okay? And that's gonna actually, we could represent it a little differently. Let's talk about 12 out of those 6 pieces that we have, okay? 12 out of the 6, but I do have a remaining number of 6 left over in the sense that, well, there's 3 that I haven't used yet, right? And if I know and remember anything about adding some fractions together, as long as I've got a common denominator, those numerators can be added together, and 12 plus 3 does give us the 15/6 that we need. So if I reduce now, as low as I can possibly go, 12 out of 6, well, 12 divided by 6 is 2. That talks about the whole number section to this. And 3 over 6 gives us our 1/2. Okay, so I can reduce this as well. Okay, so I have multiple ways to show that. Now with some fractions, it's going to be a challenge to draw all of the little pieces. Sometimes the numbers get large and it becomes a little tedious the larger the fraction happens to be, right? The larger number of pieces you have. So if I think about doing this using a multiplication statement instead, we can still show the same thing. The pattern just works a little differently. Now with that first example, before we move on, the 15 that you see in that numerator, the 15/6, can be found by using this simple pattern. So take that whole number of 3, okay, the numerator, which is 5, and if you actually multiply those numbers together, right, 3 times 5, 3 multiplied with 5 is going to get us that 15. So the same pattern is true in any case you want to multiply a whole number with a fraction. Okay, take the whole number and the numerator and you can multiply them together. So in example number 2 for us, okay, in example number 2, we can write it as, well, 3 multiplied with 2 divided by 5. Okay, and I'm going to show you all the steps here. So 3 multiplied with 2 is going to give us 6 as our numerator. Our denominator is still going to be 5. Okay, we don't change the bottom part. And there's our improper fraction. If you think about changing it into a mixed number, I have 6 pieces in total, but a whole in this example, okay, a whole is represented by 5 pieces. So I have more pieces than I need to make one whole object. So if I start to split them up, 5 out of those 6 pieces that I have make my one whole, and I have 1 piece out of 5 left over. Okay, so to change that into that mixed number, 5 out of 5 gives you our one whole, and I have 1/5 remaining. Okay, so depending on how you're asked to leave it, an improper fraction, a mixed number, both can be done there. Okay, so there's 2 examples underneath. If you'd like to try them, give the video a pause, okay, and then you can find the solutions in the answer key. Okay, the links again will be underneath this video. And we'll talk about this application question here, a little bit of a word problem before we wrap this up. Okay, so a spider's got 8 legs, an ant has 3/4 as many legs as a spider. How many legs does that ant actually have? Now some people are going to be really good about finding out the answer really before showing any work, but in math usually the answer is not super important. It's how do we get there, right? How do we explain that process? How do we show what we know? So I know that a spider has 8 legs, and I know that 3 out of 4 can be represented. That's the same thing as saying 75%, right? 3/4 is 75 cents out of our $1. There's many ways to talk about it. So in reality, I need to think about how much 75% of 8 is actually going to be, right? The 3/4 represents our 75%, and the 8 is how many legs the spider has. If I am able to find out what 75% of 8 is, well, I'm going to be left over with how many legs the ant actually is going to have. Okay, and if you know anything about percentages, one of the things we've done in the past is take a percent, turn it into a decimal, and then you can multiply by your whole number. But now that we know how to use fractions, we actually don't need the decimal for this example because we know that 75% is 3/4. The word of in math is going to mean, well, multiply. So 3/4 multiplied by 8, and now I'm in the same situation that we just talked about. So if I remember what my pattern is, I can take the numerator and the whole number, those get multiplied together. Okay, so 3 groups of 8 divided by our denominator of 4. Right? 3 groups of 8 is going to get us to 24. I still have a denominator of 4, and now if I go to reduce this one, I have my improper fraction already. If I try to change it to a mixed number, it's beautiful because it's going to leave me with a whole number. So 24 over 4, 24 divided by 4 will leave us with 6. Okay, and we have just done it. We have figured out that the ant has 6 legs. And there we go. There's our final answer. Showing all of our thinking, all of our work, everything looks good. Okay, so just a quick summary on the bottom. You can show that multiplication of a fraction and a whole number using models and diagrams. We showed it based on pattern blocks before. Multiplying a fraction and a whole number in either order gives the same result. Notice how in this example I chose to write the fraction first and then the whole number of 8. Okay, the result would be the same if I had actually swapped those two spots. Okay, the multiplication would work out the exact same way. Okay, if you'd also like, and you scroll down in that notes document, there are just some practice questions. Okay, just multiply using the method of your choice, along with a little word problem. So if you want to challenge yourself, try those out. Check the solutions in the link down below. Okay, so I hope this helps. In the next video, we'll talk a little bit more about our fractions, and we'll actually start to get into dividing. Okay, that'll be the second lesson. You'll see all the links to everything pop up on the screen in about a minute. Okay, so I hope that helps. Take care, everyone, and we'll see you in the next one.